Welcome to EclipseCon and to my little talk about our experiences implementing language servers for Eclipse and various other environments. And I talk more about my experiences doing the stuff. So I'm not giving an introduction to language server protocol. I'm not telling you exactly how to implement your own language server. It's more our experiences doing the stuff. So I think you might have heard about the language server protocol. It's an invention of the Microsoft folks doing the Visual Studio Code editor, and they did this to differentiate between and to do a split between what they call the client, which is the editor, the UI stuff, and the real, let's say, language understanding behind the scenes, analyzing source files, doing content assist, understanding the language, the syntax structures, and doing all that stuff. And the reason why they did this is because they figured out that, hey, we're at Microsoft, so we should support C# maybe as a language. And on the other side, they had this nice little code editor that they implemented in TypeScript using HTML and CSS and JavaScript, not JavaScript, but TypeScript and all that great stuff. And they thought, yeah, they went over to the C# guys and say, hey, we have this cool client editor here on the side. It's written in TypeScript. Hey, can't you do all your C# support, but just rewrite this in TypeScript for us? Wouldn't that be possible? And they said, guys, you're crazy, right? We worked for years, and there are tens of hundreds of man years built into the C# and language understanding. We will not rewrite everything in TypeScript just because you did this cool editor in TypeScript. So they put these kind of protocol in between, which is now the language server protocol, so that the client can talk to a server, and that the server can do the real language understanding, independent of the client side. By sending JSON messages forth and back. It's kind of two processes, they talk to each other. So the client tells the server, hey, I'm editing this source file and I need content assist at line 20, position 5. Please give me content assist back. And the server really analyzes the code and does the stuff. But keep in mind, it's just two processes on the same machine, right? It's running on your machine, on your laptop, whatever. It's just two processes running on the same machine, talking JSON to each other. It's not a server in the means of there's a server running on the cloud on in some data center somewhere across the globe and talking via the internet to you or something like that. So it's not a real server thing. It's just a different process on your machine. That's important, I think, to understand. So what is our background? Our background is I work for Pivotal, and we did the Spring IDE and the Spring tool suite for Eclipse over the previous years, and even decades now, I think. So our goal is to support Spring developers around the globe and give them the best developer experience. So we did this in the past using Eclipse. So we wrote plugins for Eclipse. If you know Eclipse and you installed that and maybe you looked at the Eclipse marketplace, the #1 item on the marketplace, these Spring tools, that's the stuff that we built. And that's very specifically built as plugins for Eclipse. And we thought we should maybe change this for the future. So we thought about how can we build the next generation for the Spring tools in the future. And this is what you can try out now as a public beta, Spring Tools 4, the 4th generation, which is built on the language server protocol. So that's kind of the background for my talk. And we thought about we should not only support Eclipse in the future, we should support Eclipse and VS Code and maybe the Atom IDE is kind of a third proof point for our Spring tools in the future. You can download all that. And behind the scenes, there is language server technology built for support Spring Boot stuff. So, and if you know Spring Boot, it's mostly you hack stuff in Java using annotations. So we support Java source codes, Java source files, and try to help you do your Spring app development with that. We help you work with property files for Spring Boot applications where you can customize your app. And those are in the classical properties file format or the YAML file format. And we have other YAML dialects around in our ecosystem for Cloud Foundry and for Bosch and for Concur CI systems and things like that for other open source projects that we work on as a company. So we thought about, hey, we should do this. So we implemented language servers for all of them and for all these environments. And on the client side, we supported the Eclipse IDE, VS Code, and Atom, and we did prototypes for Thea. You might have heard of that. Maybe you went to the workshop yesterday. And for IntelliJ, even though IntelliJ has great Spring support out of the box, so there's no need for us to put our stuff into IntelliJ because they already have great Spring support. But people were asking for that. Right? Once we put out the public beta of the Spring Tools 4, the first question was, hey guys, do you support IntelliJ? No, they have their own stuff and they don't support yet the language server protocol. But yeah, we tried and did some stuff under the hood to see what's possible there. And then we, of course, made a lot of experiences along the road, and that's what I'm talking about now and telling you. And I would like to encourage you to ask questions in between. So whenever you have a question, feel free to ask. I'm happy to answer questions in between. If you're running out of time, we might kind of defer the questions or move them back to the break or so. But if you have questions, feel free to ask in between. So what are the good parts? The good parts of the language server protocol, what is our experiences? We are really able now to focus on the stuff that we are good at, and we are good at building tools for Spring developers and focusing on Spring. We understand the Spring framework, we know how to build Spring Boot apps, we know what people do, we know what they need, so we can really focus on that instead of trying to learn 5,000 different APIs for Eclipse, and then, oh, we need to learn 5,000 different APIs for IntelliJ, we need to learn totally different APIs for Atom, we need to re-implement everything for VS Code because it's all written in TypeScript and things like that. So we can really build our understanding of Spring Boot into the language server, build that once, and put that into all the different clients, all the different editors. This is great for us because we don't have to deal so much with the client side, with the UI side, and we don't have to re-implement our tooling for every client. We can just reuse exactly the same thing. So this is great for people building languages and people building frameworks. They can build their language support just once. And another great advantage is that you can, because it's running in two separate processes, you can build the tooling, the language server, in a language of your choice. So you can decide, hey, I write my language server in Python. Let's go. Because I support Python, or I support very specific things, and there's so much awesome libraries in Python out there that I can reuse to quickly build my language server. So let's do that in Python. And you know, it's just possible. You can just do it because you start that up as a separate process and you're communicating JSON to the outside world. If you're familiar with the Eclipse history, you know that there is, for example, C tooling and C++ tooling in Eclipse, the CDT project. That's there for a long time. And they built everything as a plugin for Eclipse, so that what they did in the past is they rebuilt the full C and C++ parsing stuff. The whole thing, they re-implemented everything in Java because you have to build stuff in Java to make it run in Eclipse, especially in the old days. This was really kind of a horrible thing to do, of course, because it's kind of all there in C, and it's all there in C++, and all there in C#, whatever. But they weren't really able to reuse that. And you can do that with language servers. You can build the language server in the language of your choice, and this is a huge benefit, especially if you think about the different environments, right? So we work on Spring Boot, so we really love to build our stuff in Java. So we just did this, and we can put it into Atom, which is built in JavaScript. We can put this into VS Code, which is built in TypeScript, and the extensions for VS Code, they are built in TypeScript. But our language server is still running in Java, and that's great for us. Really awesome. And there are nice libraries around there. So of course there's a protocol, and you need to talk JSON. So, and the protocol is this consists out of quite a few things you can do with it. So the good thing is you don't have to really talk the protocol in detail and parse JSON stuff yourself. There are nice libraries out there. If you're working with JavaScript, you can use a Node library. If you work with Java, there's a great LSP4j project out there that gives you ready-to-use generated API in Java that talks the language server protocol with the backend. So that's great. Really easy to use. Really easy to build up your own simple language server. And the separate process stuff, I already mentioned that several times. There's huge benefits about it. You can use your own language, but it has other benefits too, additional ones. Because if it breaks, it doesn't crash your IDE. In the old days, right, if the Spring IDE stuff or the Spring tools, if they crash the whole JVM, and your whole Eclipse instance is gone. Now, if your language server crashes, sometimes you don't even notice because the UI is still running. The UI process is still running, it still continue to be responsive. You can edit files, you can save files, you can do whatever you want. You don't lose any data, you don't lose any file state, whatever. It still stays exactly the same. And if behind the scenes several language server processes, if they crash or go away, you don't care, right? It doesn't make a big difference. Of course, the functionality is gone, right? You don't get context anymore. But if the client is smart enough and the server crashes, it just restarts the language server process again, and it comes up again. You don't notice at the UI if you're good at that, and your startup is fast and things like that. That's a huge benefit because it's kind of these async nature by default gives you a lot of flexibility and a lot of responsiveness on the UI side. And of course, you can decide how to run your language server. If you run in Java, for example, you can exactly specify the JVM options, the memory usage and whatever, everything, exactly for your single language server process. You don't have to tell the user to say, oh yeah, please change your Eclipse settings to now run on 4 GB of heap because my language tooling is so expensive. And then you have to change the settings yourself or whatever. You can specify that per language server process, which is really nice. And you can use, while building your language server, all the libraries that you want. That's great. Whenever you came across these kind of, you cannot really use this library in your Eclipse plugin because if it should be compatible with Photon and Oxygen, it has to use the specific version of the HTTP Commons library of Apache. Otherwise, if you install another version, it screws everything up. You know what I'm talking about. Just a separate process. You can basically put in whatever you want for good or bad reasons, but you are completely free of the libraries that are used by the IDE process around you. Completely independent, which is great. And it's cool for Blackbox testing. Because the language server, all the language server knows is there are files on disk and there are JSON messages coming and going. So that sounds like an ideal case for Blackbox testing, right? If you want to set up a Blackbox unit test, you start the language server process, feed it with some files, and then you send JSON messages forth and back and see if the right answer comes back. For example, if you send in a request for a content assist thing, makes testing a lot easier. And you can do protocol extensions. That's great. That's nice. So whenever you come across something that you think, oh, this is not covered by the protocol, oh, the protocol is missing a specific piece, I need to improve that, I need to do more stuff, you can do that. You can implement your own messages, but there's a bad part involved in this too. Because, as you can imagine, the protocol is great because everybody understands the protocol. If you change the protocol or enhance it, this benefit goes away. Because the client doesn't know what you're talking about when you send back another message or a new one or whatever. We will come back to that in the bad parts. Another thing that's really nice about the language servers, and this is also a specific part of the protocol, is that you can decide on your own when implementing the language server what the scope should be of your language server. So for example, there are language servers out there that are specifically scoped, they can work on one project. I think the C# stuff that's used by VS Code is able to work on exactly one project. And you can, if you're working on 5 different projects, there are 5 different language servers being started, one for each project, which is great because you don't have to rebuild and rewrite the whole language server and the whole language tooling to now deal with multiple projects or whatever. The language server decided I can work on one project and that's it. And there are other language servers, for example, the Java one that you can use in VS Code that is able to deal with multiple projects. So it starts up just once, works on multiple projects. And you can decide that on your own. It's not predefined and restricted by the protocol, which I think is a good benefit. Okay, let's talk about the bad parts. Not only that fits the bad parts. Thank you. When I said the language server can decide on its own whether to work on one project or multiple ones, and if it decides to work on one project, you could of course think about, oh my god, I have a workspace with, what did Carsten show, 1,600 projects, and now magically behind the scenes 1,600 processes being started up, 1,600 JVMs on my laptop running to deal with all these projects and language servers. That sounds really heavyweight and huge, and it is. It could be. So take care if you build your own language server to not really fall into that trap. The good message here is this is kind of a solved problem because you can decide on your own, as I said before, that you can support multiple projects and you can support what's in the protocol called multi-root workspaces or multiple root folders. So the client will tell you there are multiple projects, multiple folders. Please deal with all of them. And you say, yeah, give me all of them. And then there's just one process being started up. So that's good news. Good news on that part. The other bad part is that, of course, you might have to do the work twice, as you can imagine, right? So in our case, we deal with Java code and do these Java annotation support and things like that. And on the other side, there is the Java language tooling, because we don't rebuild Java language tooling ourselves, right? The user can install the JDTLS, the Java language support for VS Code, for example, in VS Code. So that extension is running, and whenever you give it a Java project, it parses the code, resolves the class path, tries to figure out what is this old Java thing all about, and does all the stuff for you, right? And when you hit content assist, it parses the code and picks up the AST and things like that. So that's great. And then our language server starts up and says, yeah, it's Java code. I can deal with that too. And of course, in contrast to building Eclipse plugins, it has no idea about its environment. It has no idea about JDT running somewhere or the Java language service running somewhere, totally separate process. No idea about that. So you have to do something like, oh, what's the project? Oh, there's a project. Oh, let's resolve the class path myself. Let's try to find out. Let's support Maven. Let's support Gradle. Let's find out the class path. Let's do some kind of Java parsing. Let's try to find a parser that works well for Java. Let's reuse that library. Let's do all that. And it's great because it gives you a lot of independence of everything that's around you, but it causes you to do kind of the work twice, right? You have to resolve the project yourself. You have to do the Java parsing yourself if you want to, right? If you are in the situation where you do additional things to a language that's already supported. The good news is this is kind of partially solved, especially for the Java case. The bad news is it's moved to the ugly section and not to the good parts. So we come back to that ugly part later. And one of the bad parts I already sort of mentioned is you can do the protocol extensions, so that's great. on the one side. On the other side, you have to deal with all the clients yourself again. So you have to write the client side yourself, the guy that understands the messages or sends the messages or shows up something at the UI. And you have to build that for VS Code in TypeScript and for Atom in JavaScript and for Eclipse as an Eclipse Java plugin and so on. So then you are back in the old game where you have to support all your clients, which you don't really want. So my recommendation would be try to stay away from protocol extensions unless you want to be in that game again. And another kind of side effect, not really sure if it's a bad part, or some people say, hey, this is a good part. It's a server process. There's no UI. If you want to say, for example, do a specific UI for specific preferences for your language server because you want to allow the user to switch on and off specific things or put specific things in there or customize certain settings, there's no real way to do that. You have to build your own stuff, or you can go back to the, let's say, VS Code style of, yeah, there's a JSON file that contains all the settings, and whatever the client allows you to edit JSON files, we will do. And there's kind of limited support, but it's not the same as if you build a plugin for Eclipse where you can build the whole preference page yourself. Okay, so let's talk about the ugly parts. There's glue code involved. Every extension involves a tiny little bit of glue code. So to get your language server running in Eclipse, you have to write a piece of glue code. Find a little a plugin for Eclipse, an extension for Eclipse. You put your fat jar or whatever inside, implement an extension, a point, and that's it. So it's not a lot of code, right? You can write that in an hour maybe, or maybe in half an hour, or maybe in 5 minutes. But it's a tiny little bit of glue code that you have to write. And then you go to VS Code and you do the same in VS Code. Right? Tiny little bit of glue code for VS Code. And you do the same for Atom. And they're all slightly different, of course. So that's a bit ugly. I know that there are people out there thinking about kind of a standardized way to deploy language servers. So this might be different in the future, might get solved. But at the moment, it involves to write a little bit of glue code. It's a little bit ugly, but it's not a big deal. The other ugly part, and that's closer to my heart, is that the protocol has a lot of room for interpretation. So the protocol talks JSON and it talks about, oh yeah, send me back whatever content assist, and then you don't really know what the client is doing with your content assist proposals, for example. You don't really know that, right? The client can do whatever it wants with that, and some clients try to be smart, and some clients try to be not so smart. They try to be smart in sorting the stuff and finding prefixes in your code at the cursor position and filter out proposals by the prefix. Others do that not. Some do kind of what I call the magic indentation. So they think whenever you are kind of intended by 3 tabs or whatever, and you hit content assist, you get proposals back. Everything that you insert, if you insert multiple new lines, should also be inserted automatically with the 3 tabs to get kind of nice formatting. Other clients say, no, magic indentation. We don't know anything about this indentation. Maybe it's different for another language, so the server who knows the language should decide on that. And the protocol doesn't really say anything about that. So one client goes that way, the other client goes the other way, and you're in the middle with the language server. You don't really know what to return as a result of a content assist request. Should you return the new lines intended or not, with tabs or not, or with spaces maybe? Who knows? You have to deal with that. So we ended up, honestly, to implement some kind of feature flags for that. That the language server is sort of aware of the client and can deal with these different behaviors of the client, which is another really sort of bad part, an ugly part, because every client is slightly different, you end up testing every client yourself. Of course, you can do this kind of unit testing against the language server and take a look at, is the language server really, really good and is it really the right thing? But in the end, you really have to manually test all the different clients that you want to support and see, does for example, the content assist, the formatting, the UI of the hovers when they are displayed, is the markdown displayed nicely or slightly different from client to client? You have to really test every client yourself. You have to go through everything. So it's not just, we test the Eclipse plugin for Spring Boot once and then we're done. No, we test the Spring plugins for the Spring language server, the Spring Boot language server for Eclipse, and then, oh yeah, we're done. Oh, then we go ahead and say, we test the same stuff for VS Code. Oh, we're done. We test the same stuff for Atom. That's really ugly because they behave differently from time to time, and that becomes a real nightmare, I think. And the other thing, one kind of a new thing for us is we thought about we should not go into this game of redoing the same stuff all over again with the Java language server. So we should not decide on our own how to resolve a project, how to find out the class path of a project. We should really try to leave that to the Java language server and let that guy do the work in finding projects and resolving projects, and just tell us what's the project or what's the class path so we can deal with that. And also to avoid the situations where we think the project, this is the project, and the Java tooling thinks that's the project. And then kind of you get different behavior, different project resolution mechanisms in different language servers, which could really be confusing to the user. So, okay, we thought, yeah, we should reuse that. But the protocol doesn't allow you to do that. There's no way in the language server protocol to tell it, hey, let me talk to the other language server guy. I know it's there. Right? Separate processes, totally isolated, no way to communicate, and no standardized way to communicate. But the Java language server, it allows you to extend it. So you can build a plugin for the Java language server, because the Java language server is nothing else than a headless Eclipse running on with OSGI plugins and JDT core stuff inside. So it allows you to build a plugin and add that plugin. And that plugin can do specific stuff, but you can do that. But how can the plugin talk to you back? Oh, you can do some kind of, let's open the socket or do stuff on your own, which really sucks. But you can start doing kind of sending commands forth and back, and that's what we ended up doing in the same way that the Microsoft did the extensions for supporting debugging in Java and things like that. So you end up doing something like you implement an OSGI plugin that's an extension to the Java language server, and you can put that into the Java language server with a specific mechanism, which is not really standardized, but there is a mechanism. You can put that in there, and then your plugin inside of the JDT language server sends commands to the client, and then you can tell the client to send the commands back to you, and then you can do stuff with that. And this sounds really hacky, right? It sounds really ugly, and it is really ugly, and it really sucks. But it's the only way that we found that you can talk to each other and exchange this information in a more or less standardized way. But you end up building all these loose ends all over the place again, right? You build these, you build your nice language server running on Java. It's great. So it's so isolated. You can talk the protocol. That's it. And then, yeah, we have to build this OSGI plugin that extends the JDT language server. Yeah, let's do something totally separate over here. And then do have commands going forth and back, and hack the client to send the commands forth and back. And then you find out, oh, this mechanism, how the JDT language server gets this extension from us, this plugin. This works in VS Code, but it doesn't work in Eclipse. Okay, wait a second, you don't need that for Eclipse, because in Eclipse, you already have all that. So, yeah, okay, let's build the stuff ourselves. So let's put our extension plugin to Eclipse ourselves. So let's do the same stuff again. And then you go over to the Atom side and think, hey, Atom guys, what about supporting this? And they say, yeah, where's that spec and the language server protocol? We support the language server protocol. We don't want to go into the game of supporting 5,000 different strange extensions to the protocol. We want to be clean, and you can understand that, right? So you have to build this extension thing over there again. So it's great from the user's point of view if everything works, because you're resolving the project just once. You get everything back. So that's great, and that's what's working now in the Spring Boot tools. So it gives you a lot of performance improvements, a lot of memory improvements, but under the hood, building the stuff, you're really starting to build these tiny little loose ends all over the place again, which is really ugly. And we haven't found a good solution to that yet. So whenever you have an idea, let us know, or a better way. We'll be really happy to solve that. Okay. Still, I think, from our point of view, and from my point of view, LSP is still the way to go. If you want to build support for your own language, if you want to build support for your own XML dialect, YAML dialect, specific framework, whatever, and you want to really focus on that and not deal with the specifics of all the clients, you really should go with the language server protocol. It's really, really great. Great stuff. Even though there's some bad parts, some ugly parts, but really the way to go. Okay. That's the collection of my experiences that I collected for you and for the conference so far. If you want to give the Spring Boot tools a try, you can download them. It's all open source, so it's all on GitHub. If you want to take a look at our implementations, also around the bad parts and the ugly parts, all the other stuff, feel free to give it a try and download. And of course, I'm happy to answer questions. No questions. Okay. Thanks for coming. Hope you enjoyed it and enjoy the rest of the conference. Thank you.